Chapter 2. Doing Judgement. Section 1. Logic Operation. If we want to calculate the absolute value of a number, we need to judge whether the number is greater than 0 or less than 0. We introduce the if function to achieve this. The if a, b, c function has three parameters, where a is a condition. If the condition holds, b is returned, otherwise c is returned. Using if function, we can also find the maximum value of two numbers. Most modern programming languages have a data type called Boolean, which has only two values, true and false. Conditional judgment, such as the above x is greater than 0 or x is greater than y, is also understood as a kind of calculation expression in programming language, just like our conventional arithmetic expression, except that its calculation result is a Boolean value. When this condition holds, its calculation result is true, otherwise the calculation result is false. The stricter description of the if a, b, c function is that if a is true, b is returned, otherwise, c is returned. To convert a data of other types into Boolean, you can use the boolx function. Since Boolean value is also a kind of data, it should be able to participate in operation. Let's take a more complicated example. Given a year, calculate how many days there are in that year. We know that there are 365 days in a normal year and 366 days in a leap year, so we just need to judge whether the year is a leap year or not. The complete rule is this: if a year is divisible by 4 and cannot be divisible by 100, or it is divisible by 400, it is a leap year. For example, 2004 is a leap year because it is divisible by 4 but not by 100. 2000 is a leap year because it is divisible by 400. 1900 is not a leap year because it is divisible by 4 but also by 100. This is the SPL expression, where y is the year to be judged. The last two parameters are easy to understand. Let's explain the first parameter, that is, the longest expression. The percent is used to calculate the remainder of the division operation. Equals is used to determine whether the operands are equal. Y% for equals 0 indicates whether the remainder of y divided by 4 is equal to 0, that is, whether y can be divisible by 4. If y can be divisible by 4, then the result of Y% for equals 0 is true, otherwise it is false. For example, 2004% for equals 0 is true, while 1998% for equals 0 is false. SPL retained the habit of C language, using exclamation mark equals to indicate not equal to. Other comparison operators in SPL, such as greater than or equal to, less than or equal to, and so on, are the same as most programs. So, Y% 100 exclamation mark equals 0 can determine whether y cannot be divisible by 100. Likewise, 1900% 100 exclamation mark equals 0 is false, while 1998% 100 exclamation mark equals 0 is true. Similarly, Y% 400 equals 0 will be used to determine whether y can be divisible by 400. What are the remaining ampersand, and parallel? These are the Boolean operators. Ampersand stands for and, which is also usually called and in programming. Parallel stands for or, which is also called or in programming. Both ampersand, and parallel are binary operators, that is, like addition, they have two operands. These are the operation rules of ampersand, and parallel. In fact, they are the normal meanings of and, or. The priority of ampersand is higher than parallel, that is to say, if there are no parentheses, ampersand will be calculated first and then parallel, just like multiplication and division before addition and subtraction. If this expression is written as Y% 400 equals 0 parallel Y% for equals 0 ampersand Y% 100 exclamation mark equals 0, it will get the same result. There is also a very common single operand operator exclamation mark, meaning not, and these are its operation rules. Exclamation mark is a little bit like the minus sign in arithmetic, and its priority is higher than ampersand. Now, we can understand the meaning of this long expression in the if function. It really correctly expresses the rule of leap year judgment. Here's another question. Why do we use two equal signs instead of using one equal sign as in arithmetic expressions? This is because SPL retained the habit of C language and considers the assignment statement such as A equals X as an operation expression, which also has a calculation result, that is, X. For example, if we write equals A equals 5 in cell A1, SPL will not report an error but will execute normally, and we can see that not only variable A has a value of 5, but also cell A1 itself has a value of 5. Because A equals 5 is also understood as a calculation formula, its calculation result is 5, which can be assigned to cell A1. But after such an agreement, if we also use equals to judge equality, we can't distinguish it. Therefore, the C language stipulates that two equal signs should be used to judge equality, so it will not be confused with assignment operation. SPL also applies this rule. After getting used to it, we will see the advantages of this convention, which can make the code much simpler. But there is also a risk. It's easy to write equals when it's time to write equals equals. Originally, we want to judge the equality, but we made an assignment instead. We should pay special attention to it when writing codes. It should be noted that not all programming languages are regulated in this way. For example, basic language does not regard assignment as an operator. A equals 5 only completes assignment without a calculation result. It also uses one equal sign to judge equality. The advantage is that it's not easy to make mistakes, but the code can be cumbersome sometimes. Still, there is no perfect thing of the kind. Section 2. Branching structure. We can make some judgments with the if function, but in some cases, we need the if statement. Let's review the quadratic equation ax squared plus bx plus c equals 0 we learned in middle school. We can use the root formula to find the solutions, but we need to pay attention to b squared minus 4ac. If it is greater than 0, there are two solutions. If it is equal to 0, there is only one solution. If it is less than 0, there is no real solution. We will program to find solutions of the equation. The coefficients a, b, c will be filled in cells a1, b1, c1, and the resulting solutions are required to be written in cells a2 and b2. If there are two solutions, fill in both a2 and b2. If there is only one solution, only a2 is filled in. If there is no solution, it will not be filled in. The code is written like this. Sqrt in b4 and c4 is a square root function which need not be explained in detail. The point is that if statements appear in a4 and a5. If is followed by a logical expression. If the result of this expression is true, the program will continue to execute the cells to the right of the if cell. If the result of the expression is false, the program will skip those cells to the right of the if cell and go directly to the next line for execution. Note that this if is not the if function mentioned in the previous section. It may not be followed by parentheses, and it must be written at the beginning of the code in the cell. This is the simplest form of the if statement. If the condition is true, it will be executed to the right, otherwise it will be executed directly down. There is no error in this code, but there is a small problem. Judge whether A3 is greater than 0 in cell A4, and if it is true, B4 and C4 will continue. And then what? The program will still be executed to A5, and it will be judged whether A3 is equal to 0 again, but this is an unnecessary action and a waste of time. Only if A3 is greater than 0 is not true, it is necessary to judge whether A3 equals 0. How to avoid this redundant action? The code can be written like this. The if in cell A4 and the else in cell A5 form a pair. If the judgment in A4 is true, the cells to the right of A4 will be executed. If it is not true, the program will see if there is an else under A4. If there is, it will execute the cell to the right of this else. Else means otherwise, that is, the action to be executed when the previous if is not true. This program uses the formula of quadratic equation, but the premise is that the equation is really quadratic, that is to say, it assumes that A1 is not 0. If A1 is 0, the B4, C4, and C5 of the above program will be divided by 0. Let's continue to improve this code, so that it can deal with the case that A1 is 0, that is, the equation degenerates into a linear equation. Looking at this section of code, it is obvious that B4 to D6 is moved from A3 to C5 of the previous section, that is, the else processing to be performed after the judgment in A3 is not true. However, B4 to D6 takes up 3 rows, not just the cells to the right of A4. At this time, we will introduce the concept of SBL code block. For any cell, if the lower and the lower left of it are all empty, then the block area formed by the right and the right lower cells of it is called its code block. Take A4 for an example. A5 and A6 below it are all empty, so the block area from B4 to D6 is called A4's code block. For A3, the A4 below it is not empty, so its code block is only B3 to D3, and cannot be extended to line 4 because A4 is not empty. That is to say, all the cells to the right of a cell must belong to its code block, but whether the lower line to the right of the cell belongs to its code block depends on whether the cells below and to the left of it are empty. It's rather tongue-twisted to describe with words, but actually it's very intuitive from the grid layout. Look at this grid. The code block of A1 is B2 to D4, because A2 to A4 is empty and A5 is not. The code block of B1 is C1 to D1 because B2 is not empty. The code block of B2 is C2 to D3 because A3 to B3 is empty and B4 is not. The code block of C3 is D3 to D3 because B4 is not empty. The code block of A5 is B5 to D6 because A6 is empty. Code blocks are designed to limit the scope of a statement. If the condition of if is true, the code block of the cell where the if is located will be executed. If not, the code block of the corresponding else cell will be executed. The above code can also reverse the condition of A3, and the square root calculation can be done only once. The code block of A3 is B3 to D6, which will be executed when the judgment condition of A3 is established. Otherwise, the code block B7 to D7 of A7 where else is located will be executed. We have to further consider the case of equation degeneration, that is, A1 and B1 are both 0. At this time, if C1 is also 0, then any number is the solution of the equation. If C1 is not 0, then the equation has no solution. This is the improved code. When the equation degenerates to 0 is equal to 0, the code does not fill in any solution and outputs an any at the bottom right. Let's see this code, else has if in the code block. This situation is not uncommon in reality, which will lead to the wide code, because every additional layer of if needs to be indented to the right. The code is not very beautiful and easy to read. Many programming languages, including SBL, provide syntax to bind else to if after it. The previous code can also be written like this. Write the else and the if immediately following it together. These else if and the first if form a complete if statement. It's equivalent to judging a batch of mutually exclusive conditions respectively, executing the corresponding code block when a condition is established, and then ending the entire if statement. Section 3. Comments and jumps. The program code may not always be written correctly. When there is no expected result, we often can't figure out the reason. At this time, we need to debug the program to locate the error. In the early days, the primitive debugging method was to output the intermediate results of the program to see which step was wrong. The development environment of modern programming language basically provides perfect debugging function, which can execute code step by step to see whether the direction of the program is consistent with the expectation, and whether the intermediate results are consistent with the expectation. sproc also provides these functions, all on the program menu. It's difficult to describe the use of debugging functions in words. You can find it out quickly after trying several times. We won't elaborate here. SBL codes are written in the cells, and each execution unit is a cell. It's easy to check the value of cells and variables midway, and it's naturally very convenient for debugging. Now that we have learned the branching structure, the program is no longer always going from top to bottom. It may go through different paths under different data. You can use the program debugging function to observe the direction of the above programs. In the process of debugging, sometimes we want to see the running effect when a piece of code is skipped and not executed. However, if we delete this code, we may need to add it back later, which is troublesome. In this case, comments can be used. Almost all programming languages provide comment statements or functions. In SPL, if a cell starts with slash, it is considered as a comment cell. This cell will be automatically ignored and skipped during execution. If a cell starts with double slash, the cell and its code block will be ignored and skipped. You can try to add slash or double slash to some cells to see what changes will occur in the code display. In this code, A7 to D7 and D5 will be ignored and skipped, that is, the second solution will not be calculated, and the case that B1 is not 0 will not be handled. It's very convenient to use comments to control debugging. You can change this code into comments when you don't need to execute it, and change it back when you need to execute it again. The main body of the code doesn't need to be deleted. The original intention of the invention of comments is to enable programmers to write some code-related notes in case they can't understand the code after a long time. Of course, this role still exists. Good program codes always have detailed and clear comments. In SPL, the text written directly will be regarded as a constant cell, which does not affect the execution of the program. It can play the role of comments, and the role of a comment cell is more used to facilitate debugging. If statement can change the direction of the program, many programming languages also provide a more simple and crude way to change the program flow, that is, goto statement. Let's rewrite the code of solving quadratic equation to feel it. We only consider the case that A1 is not 0. There is an extra empty line in the code, but the logic seems very clear, avoiding the long if-else block. A more complete case can also be rewritten with goto. The goto statement has been controversial since it came into being. Many computer scientists complain that it can mess up the flow of programs. When a program is running normally, we don't know what will happen when a goto statement appears, and it is very difficult to debug when the program goes wrong. Therefore, some programming languages simply do not provide goto statement, and do not allow casual jumping. However, sometimes when the program level is deep, when the conditions are appropriate, jumping out with a goto statement will make the code clearer. If goto is not used, it is likely to make repeated judgments to avoid executing statements that should not be executed. Our attitude towards goto is that we don't ban it, but use it carefully. Generally speaking, we can keep this principle of always jumping out from the depth of multilayer code such as SPL code blocks that have obvious levels, not jumping in, jumping forward, not backward, though jumping backward is not forbidden. When goto has nothing to do with if, it is meaningless. Jumping forward will make the code in the middle useless, jumping backward will make the program never end. However, in SPL, if you accidentally write a program that will not end, don't worry. When the code is running, the development environment is not dead. You can use the debugging function to terminate the program.